Welcome to lesson 1.3. We're working on more postulates and theorems, and we're going to focus a little bit more on how to do proofs and some of our algebraic properties today. So first of all, what is a proof? A proof is a logical, structured argument. You provide statements and reasons for every step of the problem from start to finish. Paragraph proofs are going to provide the statements and the reasons in sentences and paragraphs. You'll write it just like you would a paragraph for English class. Two-column proofs provide the argument in a T-chart where you give your statement here, and then directly opposite you provide your reason. We number them. Your first step is always given, and you would give your second step and the reason that you can say that second step, and so on through the proof. A flow proof, which you need to add to your notes, is like a flow chart in science. We start with an arrow, that's number one, and you have your statement. And then you would have another arrow with a 2 and another statement. And another arrow with a 3 and your statement. And then off to the side, you would have a numbered list corresponding to each of your steps. So for example, we could do a word game as a proof. Starting with soft, this represents our given, and moving to love, which is our prove, changing one word at a time. And I'm going to do this as a flow proof. And so to begin, we always start with what we're given. Soft. There are multiple ways to do this, but the first thing I might do is change this to loft. And the reason that I can do that, first step is given, that is my given word. My second step is I change the S to an L. My third step, I think I'm going to change it to lift. And I did that by changing my O to an I. My fourth step, remember I'm trying to get to love, is I'm going to change my T to an E and make life. And then in my fifth step, I am going to change life to live. Oops, F changes into a V. And then you can see that my last step will become love. In there, I changed an I to an O. There are other ways to do it, but each step needs to be justified. Typically, we try to do proofs in the fewest number of steps possible without skipping any. Here are algebraic properties. You know how these work, you just may not have associated the name with them. Addition property is if A equals B, then A plus C equals B plus C. This lets us add to both sides of an equation. Subtraction property is the same thing. If A equals B, then A minus C equals B minus C. I can subtract from both sides. Now, you can interchange a little bit between addition and subtraction because obviously adding 4 and subtracting 4 and adding negative 4 are the same thing. So there's some room for those two to be used interchangeably. Multiplication, if A equals B, then AC equals BC. We can multiply both sides of an equation. Division. If A equals B, then A divided by C is the same as B divided by C. Those four represent the golden rule of algebra, which is what I do to one side of the equation, I have to do to the other. Now the reflexive property is going to seem like a strange property until we get to triangle congruence, but for now, know that it's when a number equals itself. It's like a reflection in a mirror, the reflexive property. Substitution is when you replace, even up exchange, and you're replacing values. So when we're writing this, we would say if A equals B and A plus B equals C, then A plus A equals C. And what I've done here, and I will illustrate it, is if these two are the same, wherever, in this case there's a B, I can replace it with an A because those are equivalent expressions, like 4/4 for $1. Distributive property, if A times B plus C, then A times B plus A times C. I can distribute that multiplication. Now transitive is a lot like substitution, except we are going to transfer the equality through three equations. If A equals B and B equals C, then A has to equal C. It's kind of like a double substitution. Again, there's some latitude between substitution and transitive. Transitive is a special substitution. Let's get started. So, what property lets me go from 4 times x plus 8 to 4x plus 32? That's the distributive property. That's what lets me write that next step. What lets me go from x plus 9 equals 10 to x equals 1? What changed here? Well, what changed is I subtracted 9 from both sides. So that is the subtraction property. If A equals 6 and 3A plus 7 is true, what changes here? Right here, the A turns into a 6 because they are equivalent values. So that is substitution. I have replaced the A with 6. What changes from 3y equals 9 to just y equals 3? I divided, and so that is the division property. Now we're going to get into some actual proofs. These are multiple step problems. So number 2, we always start with what we're given, 3x minus 20 equals negative 10 plus x. And we are going to work our algebra down, solving for x equals 5. That should be our ending step. So step 2, there are multiple ways to do this. So you'll end up in the same place. The first thing I'm probably going to do is I'm probably going to subtract x from both sides. And that will give me this. And the property that lets me subtract from both sides is the subtraction property. Now I'm probably going to add 20 to both sides. And that is the addition property. How do I undo multiplication? I divide. And that is the end of the proof. Now the next one is very, very similar. And so we start with what we're given, and we work our way down to the end. We start with negative 5 times x plus 3 equals 80. First thing I'm going to do is the distributive property. That is my reason that lets me do that next step. Then I'm going to add 15 to both sides. The addition property is what lets me do that. And I'm going to divide both sides by -5. And my proof is done. Now the next proof is combining math and pictures, our algebra and our pictures. In this case, we have given information in both the words, angle A equals angle F, and from the pictures themselves, angle A is equal to x plus 10, and angle F is equal to 2x minus 90. That is all given information. Now my first step, if A equals F, and A is equal to this value, and F is equal to that value, that means those values are equal to each other. And that is by substitution. And now this becomes an algebra proof, just like the ones we've been doing. I'm going to subtract x from both sides. Again, there are multiple ways to do this. And if you move a different number first, that is fine. And now I'm going to add 90 to both sides. Now our final proof is going to move completely into geometry. My given information is always the if part. And in this case, the if part is that triangle WXY is isosceles. And that is given. What does that give us? Knowing it is isosceles lets me say that 3x plus 15 is equal to 5x plus 7. And that's by the definition of isosceles. The definition is that there are two equal sides. Now we have that algebraic setup again. Subtract 5x from both sides by subtraction. Subtract 15 from both sides. Divide by -2. And that's how you work through proofs. Your homework is your 1.3 in the packet and a quiz tomorrow.